Assalamu alaikum dear students, hope you are fine by the grace of Almighty Allah. Welcome to NIEVS Home School. I am Sabreena, Haque, Assistant Teacher of Science, National Ideal English Version School, Day Shift. Dear students, today I am going to take a chemistry class for class 9 student on the based on Chapter 2. This is the states of matter, and the common thing of us that we already learned from the class 3 science book, and come to today's topic, the states of matter. Matter is such a physical entity that has mass and occupies space. Chair, table, notebook, pen, ice, water, air, each of them is a matter. All matters may exist in three different states: solid, liquid and gaseous states. They have their own characteristics and properties in all three states. This chapter will focus on these issues. Now come to three states of matter. Anything that has a certain mass and occupies space is matter. That is the common characteristics, and this is the definition of matter. Already we have learned it in several times. At room temperature, some matters may exist as solid, some liquid and some as gases. For example, at room temperature, sugar, edible salt, marble, etc. Exist as solid. Water, oil, kerosene exist as liquid, and carbon dioxide, oxygen exist as gaseous. Now come to the characteristics of solid, liquid and gas. Now solid is a matter that has specific mass, volume and shape. That means all the three things that solid has. Molecules of all matters have a force of attraction. This is known as intermolecular attraction. This is the definition of intermolecular attraction. And this force is most in the solid. As a result, the molecule in the solid stay very close and to each other to fixed states, and they take a fixed dimension which cannot be compressed with pressure. And again, a solid matter hardly changes shape when temperature is raised. Now come to liquids. Liquids have specific mass and volume but do not have specific shape. Then liquid take the shape of their container. Since the molecules of a liquid remains further from each other than those of solid, intermolecular attraction force is also less than others. That means the intermolecular attraction force is less than solid, not the others, less than solid. Such matters do not change volume when force is projected on them, but the volume increases at rise of temperature. This change of volume is greater than that of solid. Now come to gases. Gases have a specific mass but they do not have a specific volume or shape. Either the quantity of gas is put into any size of container and it takes over the full size of the container. The molecules in gases stay further than those of liquids or solids. The intermolecular force of attraction is also very low among them. A small quantity of pressure is enough to compress gases, and the same way a small amount of temperature is enough to increase the volume of such matters. Now come to kinetic theory of particles. Every substance is made of small particles which remains together by means of intermolecular force or attraction that we already learned. Now these molecules are also have kinetic force in them. That means it always vibrate. That vibration energy is known as kinetic energy. And the attempt to prove the states of substances using intermolecular force of attraction and kinetic force of the particles is known as kinetic theory, and this is the definition of kinetic theory. Kinetic theory of particles. When the particles inside the substances remain very high force of attraction, they stay together, cannot move to that much, that is solid state. That means in solid substances the intermolecular attraction force is more than kinetic force. Now in that's why they have definite shape, and here in the liquid substances they have intermolecular attraction force is less than solid, and their intermolecular attraction force and kinetic force is near about same, that means equal. And come to next one, that means in the gaseous substances the intermolecular attraction force is less than the kinetic force. That means if we apply heat, by applying heat we can increase the kinetic force or kinetic energy. That solid matter's molecule will start vibrate. If we apply more and more heat, that vibration will it will gain energy, the molecule will gain energy from the heat and it will vibrate more, and then after a certain time it will become liquid substances, and the kinetic energy and the intermolecular attraction energy will be equal. Now after applying more heat, the intermolecular attraction energy will be lesser than the kinetic energy. That time it becomes the gaseous substances. Now that means the when heat is applied, that time kinetic energy increased and the intermolecular energy is decreased. That you have to remember. That means if heat is applied to substances, the kinetic force will be increased, the intermolecular force will be decreased, and if heat is removed from substances, the kinetic force is decreased and intermolecular attraction will be increased. Now come to next lesson, that is diffusion. And the definition of diffusion is the first line, the tendency of solid, liquid or gas to spread it spontaneously and uniformly in any medium is called diffusion. And in diffusion process, solid, liquid and gas moves spontaneously from a place of higher concentration to a lower concentration. That you have to remember, that concentration of the area is make the diffusion. And remember what happened if you leave a perfume bottle with its lid open at a corner of a room. Within some times you will find the full room perfumed. This is a instance of diffusion. Students, in the unit time, how much diffusion is occurs of a substances, that is known as diffusion rate. And if a matter is takes lesser time to spread, its diffusion rate is higher, and vice versa. That means if it is take the more time to spread, its diffusion rate is lesser, and if it take lesser time, its diffusion rate will be higher. It is vice versa. Here they give a experiment of the diffusion in the room temperature. If we take a pure water in a glass jar and add some small quantity of solid pink potassium permanganate, we will observe after few times the total water become pink, and that is because of the diffusion, and that proved the diffusion of solid. And that also happened in our everyday life. We also make coffee by using coffee beans in the hot water, and after few times when we stir this water, this total water becomes mixed with the coffee, and that also another example of solid liquid diffusion. Now come for the next experiment, that is the liquid diffusion, that also taken from our everyday life. That means when we wash our white cloths, we use the blue to make it more shiner, and when we use few drop of blue in the bucket of water, that after stirring it the total water become blue. That is done here, that is the diffusion of liquid materials. That means water is also liquid and blue also liquid. That means the liquid diffusion occurs here. Now come for the next one, that means gaseous diffusion of gases, and take a glass tube. That example is related to your question answer, so you have to read this example so properly and you have to learn this procedure. Take a glass tube with both faces are open, and take 2 cotton, soak a piece of cotton in heavy hydrochloric acid, that means concentrated hydrochloric acid solution, and soak the other in ammonium hydroxide solution. This is a acid and this is a base. Now close the glass tube, fixing each of the cotton to the side of it. Here hydrogen chloride gas from hydrochloric acid solution and ammonia gas from ammonium hydroxide solution will diffuse. Within a few moments you will see a white smoke filling up the tube. It is ammonium chloride and produced in the reaction between hydrogen chloride gas and ammonia gas, and the white smoke will not be positioned in the center of the tube and it will be nearer to hydrochloric acid solution. Look, this is the figure of that experiment, and this is hydrochloric acid solution, this is the ammonium hydroxide solution soaked cotton, and here from here the ammonia gas diffused, and from here the hydrogen chloride gas diffused. But when they react, the white smoke of ammonium chloride produced, but it is nearer to hydrochloric acid solution. Why it is happened? Because which gas has lesser atomic mass, molecular mass, which gas has lesser atomic mass or molecular mass, that gas will diffuse more than that are heavier. And look, here we already calculate the ammonia and hydrochloric acids molecular mass. Here ammonia molecular mass, the nitrogen atomic mass is 14 and hydrogen atomic mass is 1. There is 3 hydrogen, so 14 plus 3 into 1 it will 17 only, and whereas the hydrochloric acids there is only 1 hydrogen, so 1 into 1 1 plus chlorine has the 35.5 atomic mass. Here you may be confused, here is 35.5. How it is possible? It is the relative atomic mass of chlorine, and when we added the 1 with 35.5 we will get 36.5. So ammonia gas is lighter than that of hydrogen chloride gas, so ammonia's diffusion rate will greater than hydrogen chloride gas. That's why the white smoke of ammonium chloride created nearer to the hydrogen chloride solution, because ammonia gas diffuse more than the hydrogen chloride gas. Now come to effusion. The passage of gases from a high pressure zone to a low pressure zone through a fine pore is called effusion. And if we take a balloon filled up with air and stick a scotch tape on the balloon, and when we make a small pore through the scotch tape, that time the air from the balloon will come out through the pore with force, and when the air pressure inside the balloon is higher than the outside. So when the air found get away, that means it find a pore, then air from the balloons rushes towards the low pressure region, and this is effusion. Like the rate of diffusion, if heat is applied, the rate of effusion also increase. Here we use CNG that is compressed natural gas. That word you have to remember. CNG means the compressed natural gas as fuel in our vehicle. This is basically the compressed methane, that means natural gas, most part of the natural gas is methane. CH4 is the methane, and this is the main component of natural gas. At high pressure, when we run our vehicles, the gas comes out from the cylinder with high pressure and run the engine, and this is also effusion of gas because this gas comes through a fine pore. And again, propane and butane gas are composed at high pressure into liquid and put into cylinder, which we use for cooking in the household. And when we open the cylinder for cooking, it comes out in the gaseous form with pressure, and it is another example of effusion. Here you have to remember the name of both gases, that is propane and butane, that is the component of the cylinder gas which is used for cooking in household. Now effusion and diffusion are by nature same kind of action, but basic difference between them is effusion requires the presence of pressure, but diffusion does not, depends on pressure. In diffusion, solid, liquid, gas matter is spread around in a plain medium, but in effusion only gaseous matter comes out through a fine pore from a container to a gaseous matter, and this is the difference between diffusion and effusion. You have to memorize this. And if we open the cylinder but do not ignite our cooker, the gas from the cylinder will just come out and mixed with air, and this is the effusion. Then the gas that comes out would spread around the room, which is diffusion. Therefore both action may take place one after another. This is a question answer of your CQ. Now this portion, that means if we open the cylinder but if we do not ignite the cooker, that time first effusion will take place, and after effusion, that means from the cookers through the fine pore, the butane and propane gas comes out, but the whole room, when this gas is spread, that is the diffusion. That means when the gas come out through the fine pore, that is effusion, and when the gaseous matter is spread the total room, that is the diffusion. Now come to burning of a candle and the 3 stages of wax. Dear students, this is the picture of burning candle. When we burn the candle, that time we get the 3 stages of wax in together, that we will learn here. Wax is a mixture of hydrocarbon. That is the definition of hydrocarbon. Organic compounds made of hydrogen and carbon are known as hydrocarbon. In the burning of a wax, 3 stages of matter can be observed simultaneously, and there is a thin liner inside the wax. This is the thin liner. This is used to ignite it. When we add fire to it, on hydrocarbon particles around the liner melt into liquid. Look, after ignite it, the wax start liquid, and the liquid wax absorb heat and vaporize first, and then vaporized wax start reaction with oxygen of air and produce carbon dioxide and water vapor. That means the vaporized wax make the fire and give us the heat and light energy, and also produce carbon dioxide and water vapor, and this portion is the solid portion of the wax. And after few times the liquid wax come here, and also after discharging heat, it will again become solid portion. That means when we a portion of liquid wax remains and turns solid again, thus the presence of heat, we see 3 stages of wax. This is also important for you. You have to learn this. It is important for your question answer. Dear students, this is your homework number 4. You have to make 5 knowledge based question and its answer as your homework number 4, and you have to submit on Saturday from 9 am to 3 pm. Dear students, I have finished my today's topic. Hope you have understood. Read the chapter properly and do your homework. Thank you. Allah Hafiz.